Where's that? Where's that? Where's that? Where's that? Where's that? Where's that?
Why would you add the double bonds if they're already?
Because when you do formal charges, you're going to find out that you're going to be placing charges that are not necessary. So if we can reduce charges, one of the takeaways was if we can add multiple bonds, and in doing so, it reduces charges, do so.
Okay.
Okay?
Yeah.
Look out for the bucket! I was a little nervous to see whether or not the projector was going to work today because it started leaking right above it last night. So far, so good. All right. Again, this should, if you want to have, like I said, your notes out and a periodic table out. And again, I'm recording this right now. I'll be posting the PDF version of this along with the recording. Okay, so you don't have to worry about copying questions down. Okay. But if you just want to like play along with this one, then feel free. But again, we'll spend a little bit of time on this, not terribly long. It's not a very super long review. So question 1 says, which of the following does not have 8 valence electrons? So we have S2 minus, AT minus, Ca plus, or D, all have 8 valence electrons. So again, we've got a list of 3 ions. And so if you think about this, S2 minus, it being a minus charge, you have to add 2 electrons. For astatine, At minus, you have to add 1 electron. For calcium, as a plus, that means you remove 1 electron. And so if you think about it, if you locate the elements on the periodic table, you will find that Ca plus has not removed enough electrons. It's only removed 1 electron, which would mean it still has 1 valence electron present. So Ca plus would be your answer. Now, if it had said Ca2 plus and had gotten rid of both of its valence electrons, then it would have a full octet. Okay? So make sure you're counting the ionic charges when you're looking at questions like this. Question 2 is a kind of a definition. What is the energy required to convert 1 mole of ionic solid into its constituent ions in the gas phase? It's one of the, it's that third piece of the puzzle we talked about early on when we were looking at energetics of bonding. Who said it? Very good. Lattice energy. Very good. Question 3. What happens to lattice energy when the magnitude of ionic charges are small and the distance increases? So it goes back to that formula where we had K multiplied by Q1 times Q2 divided by distance. Now, we didn't actually calculate this. We simply just used the position or the formula and the positions of the ionic charges, which are the Q, and the distance between them to interacting ions, which is D. D is a denominator. And so when we have small ionic charges and a large distance, that means we are going to have a decrease in lattice energy. If we had large ionic charges and a small distance, then we'd have an increase in lattice energy. So ions that are really close together or ions that are small typically have a larger lattice energy than ions that are large. Okay? So again, go review back to that little equation. I think it's about the first few sections of this chapter. Question 4, what type of bond is found in the following molecule? CO2. We have a covalent bond. Question 5, which atom is the most electronegative? Again, this one would be the one where you could use the trends. Okay, But again, since you're using that table with the values, it might be easier to use that as well. You have chlorine, rubidium, silicon, calcium, and sulfur. Well, if you just use the trends, you would find that chlorine would be the most electronegative of the group. Question 6, of the molecules below, which is most polar? As you'll see here, all of them have the common element of hydrogen. So you just need to compare their second one. So that gets to chlorine, bromine, another hydrogen, and iodine. Again, you can use the trends on this one because chlorine, bromine, and iodine are all in the same group. And so H2 is two hydrogens bonded to each other. So that's like playing tug of war with yourself. So right off the bat, we can eliminate that option. But when something is the most polar, that means it's going to have the larger difference of electronegativities. And so if we were to use the trend of electronegativities, the vertical trend, going from bottom to top of that group, we increase our electronegativity. And since chlorine is above both bromine and iodine, that means it will have the larger electronegativity value. Therefore, the difference between hydrogen and chlorine would be the largest, making it the most polar. So again, the larger the differences of electronegativities, the more polar it will be. Question 7. I'm going to give you a chance to take a look at this real quick. How many valence electrons are in the compound CH3CH2Cl? Well, carbon has 4. Hydrogen has 1, but there's 3 present here. So that's 7. Another carbon has 4. That's 11. Plus 2 more hydrogen. That's 13. And how many does chlorine have? 7. So 13 plus 7 should have 20 total. Question 8. To convert from one resonance structure to another, and this would be helpful if you'd watch the video. So in order to go from one resonance structure to another, what is the only thing that can happen? So you've got some choices. You've got neither electrons nor atoms can be moved. Electrons must be added. Only atoms can be moved. Only electrons can be moved. Or one always corresponds to the observed structure. Well, when we were talking about resonance structures, what we're talking about is the movement of electrons. Since electrons are the ones that are involved with bonding, resonance structures are the movement of electrons to form other bonds, whether it be double or back to single, between similar elements. So that's why D, only electrons can be moved, is the best answer. Atoms are not moving. It's simply the electrons. Question 9. This value is always positive because it takes energy to conduct this certain process. This is one we just looked at and just calculated. That would be bond enthalpy. And bond enthalpy is always positive because it requires energy input, therefore a positive sign, to break bonds. Question 10. Now, I was very limited in the ability to indicate bonds on here, so I've got to explain this question. So of the bonds, carbon to nitrogen single bond, carbon to nitrogen double bond, or carbon to nitrogen, I had to write triple bond because I didn't have a symbol for that. So that means the 3 lines, okay? The carbon to nitrogen single bond is blank. Strongest, longest, strongest, shortest, intermediate in both length and strength, weakest, longest, or weakest, shortest. Well, we talked about this about bond length and strength when we discussed that section on multiple bonds. And we said that the more bonds you add, the shorter the distance becomes. And also, the more bonds you add, the more energy is required. So since this is simply a single bond, that means it'll be the longest of the three types, as well as the weakest of the three types, because it requires the least amount of energy to break. So that's why single bonds are the weakest and longest of the type of bonds. And lastly, I've kind of already given this, rank the length of the following bonds from shortest to longest. You have a single bond, double bond, triple bond. Well, again, we're going from shortest to longest. So that means we have triple, then double, and then single. Okay, so the more bonds you add again, the shorter it becomes. Question list. This should take a big chunk of your multiple choice questions for tomorrow. Okay, so again, I've posted these solutions to the free response questions on Classroom. You can take a look at those in preparation for tomorrow. But again, yes, it tests on paper. Yes, and actually, glad you reminded me because I got to make copies of that. Whew. I think I got to make. I can't remember if I made copies or not. I'll have to check the copier. Anyway, so again, tomorrow, you may have your notes. You may have a periodic table. You may have the table with the electronegativity values and your problem set to do. Okay, and I'm also going to go ahead and that's what I copied. I copied the lab. I'm going to grab that. I've got the copies of the lab. I'm going to give that to you now, just so I don't forget tomorrow. Okay. And then that's it for the review. I'll get this stopped and posted